In this video, we're going to have a look at trig graphs. In particular, we're just going to have a look at the basic graphs of the sine function, the cosine function, and the tangent function, and look at some of the features of those. We'll then develop these ideas in later videos. Okay, so we will have come across trigonometry earlier down our life in school, where we would have looked at right-angled trigonometry, where we might use the sine function, maybe sine x equals opposite over hypotenuse, cos x is adjacent over hypotenuse, tan x is opposite over adjacent. You might know it as SOHCAHTOA. But these functions are so much more powerful than that. If you can go to a calculator for a moment, and if you can type in sine 0, you should find that when we type in sin 0, you get the answer 0. So what I've plotted here is I've plotted the point 0, 0. If you were to type in sin 30, you would get the answer of 0.5, and that's what this point here corresponds to. Let's get this up. This point here corresponds to 30 along and 0.5 up. And please do check some of these values. If you type in sin of 180, you should get 0. That corresponds to this point here. If we type in sine of 270, you should get -1. And we can keep doing this for all values, but then we will eventually get this general shape here. And this is going to give us an idea of what the sine function actually looks like. You will need to be able to recreate these sine, cosine, and tangent graphs yourself. Okay, so if you are ever asked to draw a sine graph, you should be thinking about something resembling this shape here. Starting at 0, cutting again at 180, and then going back to 0. We're going to have a look at this in a wee bit more detail. But essentially, this is built from plotting the points of what we put into our calculator here. So although there's not a point here for 300, well, I know if I go to 300 and I read off what that point was, I could say what the value of sine of 300 is. We've done similar tasks for cosine or cos. So if I type in, or if you type in cos of 0, you should find that the output is 1. So when x is 0, cos is 1. When x is 90, cos is 0. When x is 180, cos is -1. When it's 270, it's 0. And when it's 360, it's 1. And so, unlike the sine graph, which started here and moved up and had a shape like this, the cos graph looks more like a valley. See, it looks like a valley. It starts at 1, goes down to -1, and then back up to 1 again. The third graph we're going to have a look at is the tan graph, the graph of the tangent function, which looks quite drastically different. If we type in tan of 0, we get 0. But if we type in tan of 90 into our calculator, you get a math error coming out. And you'll notice here that if we go to 90, there isn't actually a value. This will continue up for infinity and down for -infinity. Okay, so here we've just had a look at how these graphs are built. We're now just going to talk more about the features of them. Okay, so we're going to have a look at drawing the graph of y equals sine x, the sine graph. Okay, so we've got our x-axis and we've got our y-axis. Okay, so if you're ever asked to recreate the sine graph, y equals sine x, sine starts at 0. Okay, and it will have a shape roughly resembling this here. That's actually not my best attempt. I'll try and do that again. Starts at 0. Look, sine graph looks something like this here. Okay, we would refer to this as one full revolution of a sine graph. Okay, the sine graph started at 0, and if we referred back, we would say one revolution of sine ends at 360 degrees. Some other important features that if you were ever asked to draw a sine graph, you need to include this value here, 180 degrees. You need to include this value here, 90 degrees, and you need to include this value here, which is 270 degrees. the sine graph goes up to 1 and down to -1. You will hopefully notice that this here looks very similar to this here, but it's just reflected. Okay, that's really important. You can't, for example, have something looking like this here. Okay, this here would not be a sine graph because, or the graph of sine x, because there's more above than there is below. We want it to be equally shared above and below. We also want it to try to make it quite symmetrical about this point here. There's like a rotational symmetry to the sine graph. Okay, so if ever you're asked to draw a sine graph, you would be expected to draw what we've seen here, starting at 0 up to 1, down to -1, 1, -1, and you must put in these points. You're going to be doing a lot of drawing, so this will become quite automatic, but I'd suggest you draw this quite a few times. Okay, draw this quite a lot just to make sure you're comfortable with it and keep checking against it. So when you're asked to draw a sine graph, this is all the information you're expected to put in. Okay, so let's have a look. The max value, well, the maximum value of sine is the highest point it gets up to. The highest point it gets up to is here. Okay, so the max value is 1, and that occurs when x is 90. Can I ask you just to copy this table down into your jotters, please? Okay, if the max value is 1, if it goes up to 1, doesn't go higher than 1, the minimum value is -1. And that occurs when x is 270 degrees. So we could see here that the range of this function is in between 1 and -1. It doesn't go beyond 1 and -1. Where does it cut the x-axis? Well, we see it cuts the x-axis at this point here, it crosses it here, and it crosses it here. So there's 3 points at x equals 0 degrees, x equals 180 degrees, and x equals 360 degrees. Okay, so you need to be able to try and internalize this into your head and have an idea of what it should look like. The sine graph starts at 0, goes up to 1, down to -1, and there's a full revolution within 360 degrees. We essentially think about this as the halfway point. The first point where it crosses, the second point where it crosses the x-axis is 180. We go halfway in, then halfway on to get those points there. Okay, so that's the graph of sine x. We'll do the graph now for cos x. Okay, we'll do a similar process. So sine started at 0, but cosine, the graph of the cosine function, starts at 1. Okay, so it looks something like that there. Once again, it's a wee bit hard to do on a tablet. I'll try and redo that actually. Yeah, something like that. Okay, so we would say that this is a graph of the cosine function. It almost looks like a valley. Okay, it starts at 0, or the function starts at 0 on our x and our y axis. Okay, but importantly, the cosine function starts at 1 and goes down to -1. Just like the sine function, this value here is 360 degrees. We say that one revolution of cos ends at 360 degrees. We call that the period of the function. Okay, the amount of time it takes for one revolution for the cos graph to happen, because this graph does just keep going on and on and on and on and on, like so. Okay, so once again, we need to mark on the halfway point, which is here, that's 180 degrees. Mark on the halfway point, which is 90 degrees. Mark on the halfway point, which is 270 degrees. Okay, so if ever you're asked to draw a cos graph, you need to be able to draw something that looks like this. The cos is the graph that looks more like a valley compared to the sine graph. It starts at 1. Oh, sugar. Oops, I just rubbed that out. I'll try and do that again. It's a wee bit harder this time. Yep, that's okay. It starts at 1, goes down to -1 and back up to 1. Okay, so this is one revolution of the cosine graph. Okay, so you need to be able to try and internalize this in a picture in your head. Okay, so the max value of cos is 1. That happens when x is 0 and when x is 360 degrees. Do you see that? We hit that value of 1 twice. We hit it here and here. The minimum value is -1. And that happens when x is 180 degrees. And it cuts the x-axis at 2 points, at 90 and at 270. Okay, so that's the graph, of the cosine function. Finally, the tangent function. Okay, this one's a lot harder to draw. Okay, so the graph of the tangent function looks a little bit like this here. Okay, I'll just try and pop in some lines here to help us out. Wait, I've not done this the best I probably could have. I'll try and start this again. I'm going to pop those dashed lines in first, actually. I'll explain what these dashed lines are in a wee second. Let's pop that in there. Okay, so the graph of the tangent function looks a little bit like this. And then, okay, so once again, the finishing point here is 360 degrees. The halfway point here is 180 degrees. Then this point here is 90 degrees. And this point here is 270 degrees. But unlike the sine and the cosine graphs, it doesn't have a maximum and minimum value. It doesn't go up to 1 and down to -1. It goes up to infinity and down to -infinity. So see here, for example, see if I typed into a calculator tan of 89, I'd get a really big value. But see if I typed in tan of 91, I'd get a really small value. If I typed in tan of 90, my calculator would come up on math error. Okay, the tangent function never touches, or there is no value of tan at 90. Similarly, at 270 degrees. I'd say this is probably the hardest one to draw. Okay, so these red dashed lines here are what we refer to as asymptotes. The tangent function approaches this. The closer and closer we zoom in to 90 degrees from the left, it's going to get really close, but it will never touch. Similarly, to the right of 90, it's going to get really close, but it's never going to touch from below. Okay, so we have got two asymptotes. We've got an asymptote at x equals 90 and x equals 270 degrees. And it cuts the x-axis at x equals 0, x equals 180, and x equals 360. Going forward, we're mainly going to be working with the sine and cosine graphs and drawing them with different periods and different amplitudes, which will explain what they are and what that all means. Okay, so make sure you've got all this information into your jotter, and we're going to start building upon this. Thanks.